Okay, the lesson is now recording. Okay, so guys, before we even begin talking about our topics on today, I just want to give you guys an idea about what to expect for this entire week. So we are actually in the last week within this marking period. I don't know if you guys knew that or not. I know even though technically this week is week 5 of the marking period, they are ending the 6 weeks after this week. So that means this Friday, um, all of your grades, anything that you haven't submitted, everything must be turned in by this Friday if you want to pass for this 6 weeks period. Okay, so we're ending the fifth 6 weeks of the marking period this Friday. I want to let you guys know that. So on today, what we're going to be doing on today, we're going to talk about Coulomb's law. Because remember, we started talking about electrical charges last week. We're going to kind of go into more detail with that on today. So we're going to talk about Coulomb's law on today. On Wednesday, the district wants us to give you guys a common assessment. So what's going to happen on Wednesday, you guys are going to come in. I'm going to kind of discuss a few things, and then I'm going to let you guys go so you can take your common assessment if you want to get started on the common assessment on Wednesday. Now, Friday, I'm not going to give any additional work on Friday. I'm going to use Friday as a makeup day. So, guys, basically any assignments, any quizzes, any tests that you guys have not gotten done by Friday, get that done then. Because remember, grades are going to be submitted on Friday. Friday is the end of the marking period. So, everybody got that? So that's what we're going to be expecting on this week. So today we're going to talk about Coulomb's law. On Wednesday, when I see you guys, I'm going to post the common assessment. And then on Friday is a makeup day to get everything turned in that you have not gotten turned in up until this point. Okay, whether that's quizzes, assignments, tests. And of course, if I were you guys, I would check gradebook and to see what you're missing, because I took the time yesterday to update gradebook. It took me a while because there was a lot I had to get through, but I did update gradebook yesterday. So be sure to check through that to see what you're missing and to begin the process of getting that turned in this week. Definitely have everything turned in by Friday, because Friday ends the fifth 6 weeks. Friday ends this marking period. Any questions about what to expect this week? Okay, so let me go ahead and share my screen, and let's begin by going over what is in Schoology. Okay. So, today is April the 19th. So I'm going to click on the folder for this week. It's April the 19th. And it is a Monday. Okay. Now, as I said on today, we're talking about Coulomb's law. Coulomb's law. So last week we talked about the properties of electrical charge. Today we're going to elaborate more on that with Coulomb's law. So before we get started on Coulomb's law, and before I do a few of these questions with you all on the assignment, I want to briefly talk about briefly explain what we talked about last week. So remember last week we talked about the different particles in the atom. So guys, you may remember what I said. If you have two particles, let's say we have one particle that has a negative charge, and you have another particle that has a positive charge, and you place those two charges next to each other, what's going to happen? Anybody remember? So like I said, like suppose I'm holding these two charges in my hand. And imagine that I place these two charges next to each other, and then after a few seconds, I decide to just let my hands go. What's going to happen to these two charges? Well, in this case right here, opposites will attract, so they're going to be drawn toward each other, right? So because one is negative, one is positive, opposites attract. Okay. So remember that, guys. What if I had something like this? What if I had two charges next to each other, but they were both negative? One charge had a negative sign, the other charge had a negative sign. And again, let's assume that, I was holding these two charges right next to each other, and I released them. At the moment that I let my hands go, what's going to happen to these two charges? Well, since these are two light charges, it should be obvious that they are going to repel each other. So that's going to look something like this. They're going to fly away from each other. Okay, so everybody got that? Opposites attract, like charges repel. So please remember that if you have a positive and a positive, or a negative and a negative, and they're right next to each other, they're going to repel each other. But anytime you have a positive charge and a negative charge, they're going to attract each other. Okay, and I showed you guys an example of this last time, how you can see this attraction in nature, because this little girl here, she has a comb, and as she's combing her hair, remember what friction is doing. Friction is taking friction is taking electrons from her hair, and it's putting the electrons on the comb. So the negative charge of the comb attracts the positive charges on the water molecule, and that's what causes this bending effect right here. So there's an attraction. Okay, and again, like I said, that's a really good experiment to try at home if you guys have never tried that before. Okay, if you're just now coming in, please click on the link to the attendance form and get that filled out, please. Okay, now with that said, let us talk about Coulomb's law, which is the main topic of today. Coulomb's law. Now, okay, so remember what I just said. If you have two charges next to each other, one charge is positive and the other charge is negative. Remember what I just said. These charges are obviously going to attract each other. But how do we know the strength of the force of this electrostatic attraction? Well, that's where Coulomb's law comes in. Coulomb's law, guys, allows us to mathematically quantify the strength of the forces between two particles. So let me write this down. So Coulomb's law basically, guys, Coulomb's law says that anytime you have two charges and you have them next to each other, the electric force between those two charges, so the electric force between those two charges is equal to Coulomb's constant K times Q1, the charge on the first object, times Q2, the charge on the second object, all of that divided by the distance between the two charges squared. Okay. So guys, if I were you, I would write down this equation because this is an important equation in physics known as Coulomb's law. And let me be sure what I'll write down what each of these terms mean. Okay, so Fe stands for the strength of the electric force. So Fe, the strength of the electric force, and that is in newtons. So K stands for Coulomb's constant. Coulomb's constant. And guys, this value here, Coulomb's constant, it is always 9 times 10 to the 9th power. Okay. Please remember, that is Coulomb's constant. That is always what Coulomb's constant is. It's a constant, right? So, guys, whenever you're using this equation here, you're going to always plug in 9 times 10 to the 9th power into K. Okay. In just a moment, I'm going to show I'm going to do an example for you guys. Q1 stands for the charge on the first object. So charge charge 1. Q2 stands for the charge on the second object. In other words, charge 2. And then R stands for the distance between the two charges. Distance between the two charges. Distance between. Okay. So hopefully everybody got that down. So, guys, this equation just tells me if I have two charged particles, let's say a positive charge and a negative charge, and I place those two charges directly next to each other, and if I want to know how strong those charges are pulling on each other, then I will just use this equation here, where K stands for Coulomb's constant, 9 times 10 to the 9, times the charge of the first object times the charge of the second object divided by the distance between the two charges squared. Okay. So now that I've written down this equation, guys, here's what I'm going to do. I'm going to finish this day doing a few of these problems with you guys using this equation because I want to be sure everybody understands how to do this. So, guys, if you are right now at your computer, please open up Schoology. Open up Schoology, and we're going to do a few of these together. There are a total of 8 problems. I'm going to do like a couple of them with you all, and then the rest you're going to do on your own. Okay. Okay. So let me see. What's the first one that I want to do? You know what, guys? Look at this. Look at this question right here. Let us do this one together. Okay. So, guys, if you're in Schoology, so this question right here, it says an 8 Coulomb charge is 5 millimeters away from a 10 Coulomb charge. Find the force between them. Okay. So let us open up a blank sheet of paper so we can, or a blank sheet, so that we can do this one right here. Okay. All right. So, okay. So what we want to do, if we want to find the value of the electric forces between these two charges right here, so I need to look at Coulomb's law and then plug in my values into Coulomb's equation. Okay. So in order to find the strength of this electric force, this is what you guys would do. So the electric force is equal to, remember, Coulomb's constant K, which is always 9 times 10 to the 9. So write that out. So 9 times 10 to the 9th power. Okay. All of that times the charge on the first object. So what is the charge of the first object? It says 8. It says the charge of the first object is 8 coulombs. So this times 8 times the charge on the second object, which is 10 coulombs. So that times 10. Okay. All of that gets divided by R squared. And remember what R in this equation stands for. R stands for the distance between the two charges. So what is R here? So guys, notice what it says. The two charges are 55 millimeters away from each other. So 55 millimeters is our R. But one thing that I want to say, guys, whenever you're using this equation, R must be in meters. It must always be in meters, not millimeters. So if you go to Google, if you type in 55 millimeters to meters, okay, notice we see that there's well, if you type in 5 millimeters to meters, we notice that we see that 5 millimeters is equal to 0.005 meters. So I'm going to put 0.005. And remember, guys, that number always gets squared. So we're going to square that. Okay. Okay. Now, guys, whenever you are working out these problems here, this is what I will recommend you do. You find what the numerator is first, then find out what the denominator is first, and then just divide the two. So I'm going to go to Google, and I'm going to type in calculator. I'm going to show you guys how to do this calculation. Okay, so let's look at the numerator first. The numerator says 9 times 10 to the 9. So I'm going to do 9 times 10. Remember, hit this key right here, and then raise it to the 9th power. 9 times 10 to the 9. Remember, this is your exponential key right here. All of that gets multiplied by 8. And all that gets multiplied by 10. Okay, so everybody follow me? So 9 times 10 to the 9 times 8 times 10. If I press equal, I get this really large number here. So let's see, how many zeros is that? 1, 2, 3, 4, 5. Okay, so I get this really large number right here. So it's for my numerator. Okay, so that's my numerator. Okay, and then what is my denominator? My denominator is 0.005 squared. So I'm going to put that in my calculator. 0.005, and then square that. Okay, remember you raise this, press this key here to raise that number to the 2nd power, and then press equal. So I get 0.0025. 0.000025. All right, guys, now last step here, you just take this number and divide that by this number, and that'll tell you what is the strength of the force between those two particles. So let's do that now. So when I put that in my calculator, okay. So guys, when I take this number and divide this by this number, my calculator, this is what I get from my electric force. Times 10 to the 16 newtons. Okay. So if I go to my answer choice right here, notice I see that here. 2.88 times 10 to the 16 newtons. So, any questions on what I did there? Any questions? So all I did was just put everything into my equation, figured out my numerator, figured out my denominator, divide the two, and I got 2.88 times 10 to the 16 newtons. So that is my answer. All right, guys, I want to do one more problem like this, and then I'm gonna talk about one more thing, and then I'm gonna let you guys go after that. Okay. Again, I just want to do enough just so you guys get the point. I'm not gonna do all of these with you guys. I'm just doing enough for you guys to get the point. Let us do another one like this. Let's see. Okay, look at this one right here. Let us do this one. It says, this one right here says, a 30 Coulomb charge is 0.007 meters away from an 8 Coulomb charge. Find the force between them. So once again, we're going to use Coulomb's law to figure this out. So let me open up a new page. Again, this is the last mathematical problem I'm going to do with you guys. I just want to do enough for you guys to get the point. Okay, so let's get ready to plug everything in. So Coulomb's law says the value of the electric force is equal to, remember, Coulomb's constant K. Guys, K is always 9 times 10 to the 9. So you're going to use it in every problem. So 9 times 10 to the 9. Okay. And then all of that gets multiplied by the charge on the first object. So this charge is 30 coulombs. So that times 30. Okay. All of that gets multiplied by the charge on the second object, which is Q2. Okay, what is the charge on the second object? Notice it says the second object is 8 coulombs. So we're going to put in 8 there. Okay. So that's our numerator. Okay. And then now, notice after we plug everything in for the numerator, we have to divide everything divided by r squared, where it's understood that r is the distance between the two charges. Well, notice it says this charge and this charge, they are 0.007 meters away from each other. So that's already in meters. So all we do is just take 0.007 and we put it into the equation, 0.007. And then you want to square that, right? Your denominator gets squared. Okay. So, okay. Now remember what I said to do. You want to figure out what your numerator is first, then figure out your denominator, and then finally divide the two. So that's the best way to ensure you get the right answer without your order of operations being incorrect. So let's look at this. So 9 times 10 to the 9th power. Oh, I'm sorry. Okay, 9 times 10. Remember, I always press this key right here whenever you're raising something to another power. So 9 times 10 to the 9th power times 30 times 30 times 8. Okay, so 9 times 10 to 9 times 30 times 8. When I press equal, this is what I get. I get 2.16 times 10 to the 12th power. So 2.16 times 10 to the 12th power. So let me write that down. So 2.16 times 10 to the positive 12. Okay, that's what this number right here means. 2.16 times 10 to the positive 12. Okay. So then I take that. So that's my numerator, guys. Okay. Then I have my numerator. I want to figure out my denominator. What is 0.007 squared? So if I go here, clear this, I'm going to go 0.007 and then press this key here, and I'm going to square that. 0.00 squared. I get 0.00049. So 0.00049. Okay. So that is my denominator. Okay. So now, guys, after you have this, you can type this in the calculator and divide that by this number, and that should tell you the value of your electric force. Okay. So let's do that now. Okay, so guys, when I put that in my calculator, this is what I got. My calculator gave me 4.4 times 10 to the 16th power. And again, the value of electric force is going to be in newtons. So 4.4 times 10 to the 16th power, and that is in newtons. So if I go here and I look for that, so I see that here, 4.4 times 10 to the 16th power, and that is in newtons. So that is the value of my electric force. Any questions? Any questions? All right, guys, before I let you guys go, there's one more thing that I want to talk about. And that is, look at this question right here. Since they're going to talk about this on the next test, I want to be sure that you guys understand this. When it says, what is the definition of a conductor? Okay. Guys, you guys may have heard the term before, conductors and insulators. Remember, guys, the difference between the two. Conductors are materials that allow electrons to flow easily through them. Okay. An insulator is a material that does not allow electrons to flow easily through it. And let me, guys, give you an example of this in case you guys see these concepts on the next test. Let me show you guys an example of two materials. One's a conductor and one's an insulator. Okay. So you guys have seen styrofoam cups before. Styrofoam cups, these are good examples of insulators. The electrons that make up this styrofoam cup, they're not freely moving around the material. For the most part, they're stuck in one place. Okay. Now, imagine that you compare that to a conductor. So, for example, imagine metal. Metal is a good example of an excellent conductor. So, you guys may know that we have atoms here, and these atoms obviously have. Hold on, let me make this bigger so y'all can see this. So these atoms here, you guys may know that obviously we have atoms that have positive charges, in the nucleus, and then going around the nucleus are a bunch of electrons. So going around the nucleus are a bunch of electrons, which is what I'm going to draw here. So guys, it turns out, guys, these electrons along this spoon, they're moving all over the place. So it kind of imagine the motion being chaotic, and they're just kind of moving and scattered all over the place. That is different from a insulator. In an insulator, the electrons that make up the insulator, um, uh, these electrons, for the most part, they stay confined within this one spot. All right. So conductors are is what they're sound. Well, it's what they sound like. They're excellent at conducting electricity, whereas insulators don't conduct electricity very well. That's because these electrons stay put. So with that said, when it says what is the definition of a conductor? It's a material that allows electrons to flow easily through it. Again, just something I want you guys to keep in mind in case you guys see those concepts on the next test. All right, any questions? The rest you're going to finish on your own. So I just got you guys started so you guys can understand what you're doing. For those of you guys who have not filled out the attendance form, please do so before you leave for the day. The assignment is already in Schoology. You guys can already pull it up. Again, I've already done 3 of them for you all. If you guys need to go back and look at this video to see how I set up the problem, this video will be posted on YouTube shortly. If you guys don't have any immediate questions for me at the moment, you guys are free to go. Enjoy your day, everyone.